In this video, we will prove the proposition A and A implies B twice. We will want to prove firstly using lambda terms directly, and secondly, we will do a proof using tactics. For the proof using lambda terms directly, we start, as always, by putting an underscore in the place where the proof should go. Then lean on the right-hand side shows us what the goal statement is. It is A and A implies B implies B. The main connective here in this formula is the implication. The implication binds less tightly than the and. That is here. So we should think of this part of the formula as being in parentheses. When the goal is to prove an implication, we usually start with the tactic with the lambda term assume h, or another choice of variable. And then the goal statement transforms into proving just the thing on the right-hand side of the implication. And we get a hypothesis of the hypothesis in the context of the thing on the left-hand side of the implication. So now we have a proof of A and A implies B that we can use to prove B. In order to prove B, we use the second component of H. Think of H as a pair of a proof of A and a proof of A implies B. We use the second component, the proof of A implies B, to reduce the goal from B to A. So we are going backwards from B to A by using the second component of H. This is done by typing h.to and then an underscore. And now we see that our goal has transformed from being B to being A. So we have gone backwards in this implication. In order to prove A now, we will use the first component of H, this thing here. And this is done simply by typing h.1. This concludes the proof of this proposition A and A implies B using lambda terms. Now we're going to do the same. We're going to write another proof using tactic mode of the same proposition. The tactic mode is introduced by the keyword begin. And when we place the cursor within the tactic, within the two lines between begin and end, on the right-hand side, we are shown the goal. A and A implies B implies B. The proof using tactics do essentially the same steps, or not just essentially, but exactly the same steps as the proof using lambda terms. The tactic corresponding to assume is called intro, for introduction. So we introduce a variable h, and that transforms the goal into just proving B, where we have a hypothesis h of type, or a proof of the fact that A and A implies B. In order to continue in our proof, we do the same step as before, reducing the goal, going backward from B to A by using the second component of H. This is done using the keyword apply. We apply h.to, going backwards, and our goal statement has changed from B to A. Sorry, from B to A. So we have gone backwards using this implication. And now it remains to prove A, and this is simply done by applying the second component of H, the first component of H, sorry for that. And this concludes the goal statement. This concludes the proof, and we have nothing else to do. And this is the second proof of the statement that A and A implies B implies B.